Good afternoon, everyone. We are Team Vera from Grambling State University. I am Emmanuel Nnanna, and I'm presenting alongside my teammates David Nintang and Iminabo Roberts. So Louisiana is set to boom with carbon capture, utilization, and storage projects, attracting up to $76 billion in capital investments across the states. However, there are still some major problems that stagnate these developments. Let's watch this video for more context.
Well, today, Louisiana Governor Jeff Landry signed an executive order targeting carbon capture and storage limits. The order establishes a moratorium to prohibit consideration of any new applications for CCS projects in Louisiana. It's a way to enable the Department of Conservation and Energy to focus on the 33 applications they already have received. The department says they have a backlog of projects, and each takes about 2,000 hours of review before they can issue a permit. And the entire permitting process can take upwards of 2 years. To speed things up, Governor Landry is directing the DCE to focus on the ones it already has over the next 45 days.
So, Vera decided to investigate this video in the context of our challenge, and we also spoke to a representative from Baker Hughes to get insights and back up our problem. And some of the problems we discovered from this is that one, compliance and reporting is largely outdated, inefficient, manual, and lacks centralization. The second problem we discovered is that reporting for companies have become a nightmare. Companies have to report to multiple agencies, and most of the times they miss the reporting deadlines and do not submit their reports at all, or they end up submitting incomplete reports. Now, what does this lead to? Another problem. It leads to lack of transparency among the public, the markets, and the regulatory bodies. Because when these companies fail to report or under-report their data, it creates a discrepancy between what the public sees being claimed and what is actually happening.
But there's an opportunity. In recent times, satellite sensing and open data like climate trace data makes it verifiable and make it very easy to make independent, unbiased verification. And currently we have AI techniques that can process large amounts of documents that would have taken hours or even weeks of work into just days. So at Vera, we decided to build a centralized CO2 reporting and verification platform that would connect industries, regulators, and public markets in Louisiana. So for our software, we have different segments. First is the companies, they have their own dashboard. The second is the regulators, and then the third is the general public. We'll do a demo of what comes next after this. So for the regulators, they have a dashboard that allows them to see all the various companies or industries that are reporting to them. They can perform some flow-through analysis to sort of group by category or group by sectors, and all of this will be based in their parish. Among these facilities too, they can also view them in depth and then view specific data for these specific facilities, and then see whether they are reporting their things on time or how their reporting is as compared to climate data. And they can also have a session where they can view reports that have been submitted to them. So if they find any issues with them, they can also analyze them or maybe submit a ticket. And these are various analytics tools for them to use for the companies. The second session that we have is for the companies. So for them they have their own dashboard where they can see or track their compliance status with the various institutions that they are reporting to. They can also analyze their own facilities, CO2 trend lines to account for net emissions, as well as have a compliance timeline to make sure that they are reporting on time. And when they are reporting their data to you, they can also upload the already existing PDFs or documents that they submit to these institutions. And then based on our retrieval augmentation methods, we can actually pass all of these data with large language model and also align the data to sort of see which ones map for the various reporting bodies. So for EPA, CPA, which most of them are common, and then we have the auto-map features to apply all the various calculations or conventions that are required by these different institutions. So when they're done with this, they can then analyze or validate the data, and then it is ready for some submission or reports. And after this, they also have a reporting dashboard where they can also see which of their submissions are actually submitted, and then maybe which of them are being processed or validated or have been left as comments. And this is the most interesting part for us. It's the public view, which is actually provides an interactive natural language interactions with the kind of data that exists out there for users to understand emissions over there. So an example would be top 50 emissions in Louisiana, and then based on like climate trace API, it will list all of these facilities. And as you can see from the colors there are various sectors that individuals or researchers can actually use to filter. And what is even exciting about this is that you can tap on a specific facility and learn more with AI. So currently we have AI search agents that pulls recent data as well as data sets of PDFs or files related to it. And you can basically have a general understanding of maybe the particular facilities based on your research. So maybe if you had found one that was interesting to you, you can use the AI to learn more about it. We have different sub-agents that we are using. Some of them include trends over time, analyzer, which sort of like generates graphs based on how these like reports that have been submitted. Currently, just like these 3+, because based on our API, these are the only ones we can get. But we're also getting other agents like statistics, top emitters, and comparing of regions.
So when it comes to our user unique value proposition, for the companies, you can report once and it reports for all different agencies. So instead of reporting once and changing it for every agency, just report once. For the regulators, they can have easy verification and monitoring. They can also know when there's a discrepancy easily from our web app, and also have foresight. So they can, for the policymakers, they can write down their policy on the AI chat bot, and it can tell them what are the possibilities that can happen in a specific state if they implement this policy. Then for the public researchers, they have AI natural language processing. So it tells them, especially non-experts, to understand what's going on around them when it comes to climate change. Then for our technologies, we use LangChain for RAG and document extraction to make it more precise, the AI more precise. We use Llama, precisely we use Llama 3.3 for our AI model. We use PostgreSQL for our database, Python for our backend, and Next.js for our front-end interface. Then for our next steps, what we plan on doing is to refine the agents to make them more robust, connect official APIs such as EPA APIs to our system, not just climate trace API, to make the system also more robust, partner with other agencies, and also have mentorship for the non-experts.
And in case you're wondering what our impact and vision is, well, it's simple. We wish to create a world where regulators don't just have to delay CCUS projects due to lack of transparency or community engagement. Thank you so much for your time.